been a very large earthquake.
I'm Claire Bailey, and this is Made with Android. I'm headed to the Cognitive Science Robotics Laboratory at the University of California in Irvine. They've got an Android-based robotics platform that they're using to researchers' navigation with neural networks. It's a technology that could one day save a lot of lives. Let's check it out.
The lab is called the Cognitive Anteater Robotics Laboratory. Anteater is UC Irvine's mascot.
Awesome.
And so it makes a nice acronym, CARL, so all our robots are called CARL. And the mission of the lab is the brain is embodied and the body is embedded in the environment. They can't work in isolation. Brains are always actively sensing and acting in the world, so that brought in the robotics point.
So what's the point of your research?
So the point of the research is to understand how the brain works. And so if you actually have a model, you can look at every aspect of the brain. You can't do that in real brain. So we can look at every single nerve cell, every single connection while it's learning, while it's behaving. So we can take information from people who work with real brains and then put it in our artificial model. Then we have this powerful history of what was going on in this artificial brain.
4 years ago, I wanted to build my own robots, and most of the inexpensive robots are not that powerful. I decided to start looking into how to use a smartphone, especially an Android smartphone. And then it started as a hobby, and then later on I showed that to Professor Kretschmar, and we decided then to use this platform. People can use their own smartphones to build pretty interesting robots. We want people to be able to download the code and build their own robots and replicate what we've done, but also add their own projects.
Currently we have 3 working robots, and they use the Android phone. So the Android already has GPS, it has a camera, it has a compass, and we use all of that on our robots.
Tiffany just gave me some quick tips and I was off and running. I currently build all the robots and I currently break them. They're in testing and I fix them and get them better again.
I've only taken 1 class in Android programming.
It's all about having fun, and using this has been really easy.
More than half of what I learned is just from playing around with these robots.
This is a search and rescue robot.
So first it's going along a road, and then it sees the victim.
And after it does that, it IDs the person, it turns around and goes home.
Where it can report all the details to the computer.
So you just need something orange?
Yeah.
We're trying to understand how the brain processes motion, mostly motion from just visual input. There's a lot of animals out there that are really good at it. We looked at honeybees, for example. One thing they seem to do is to look at the flow on the retina, on their eyes. And by judging different structures that evolve from this flow, you can make decisions about where you want to go. For example, you could see an obstacle pop up in front of you, in which case you want to move to the right and avoid it.
Right.
Maybe you have a goal, like fly towards something, then you are very directed towards that and can avoid everything else and steer towards that. And we're trying to understand how that works in the brain and how can we build a model, an artificial system that mimics these processes. My robot is programmed to follow this yellow ball. And as it moves along the hallway, it will actually avoid obstacles along it. Finds the bucket. So in this little frame right here, you can see what the robot actually sees, his field of view. That's not entirely correct, because what he sees is a crude version of that and only the lower half of the hallway, which is shown here on the right. And I can control the robot with the keyboard. So as I drive along the hallway, you can see these arrows show up, which tell the robot that there is something nearby that causes optic flow on its visual field. So when I drive up to an obstacle, you can see that more arrows pop up, and that will be a sign for the robot to turn. We want this to be a mobile, fully autonomous platform so that it could explore landscapes by itself. Maybe there's been a hazard, an emergency, some earthquake or something. There's victims out there. And the robot could then go navigate maybe cluttered, complicated landscape and find the victims, maybe save them or send a signal so that others know where they are without any human interaction.
You could have multiple robots, so you could have them in a swarm, and they can work effectively as a team to figure out where all the victims are. And the good thing about this is that since they're robots, we're not too afraid if something happens to them, so that's the plus of using robots in the rescue scenario.
If you wanted to mine for minerals, do any human intensive tasks like gather crops, because this robot is just a base. We can mount anything we want on top of the base. We can mount an arm, we can mount anything. Possibilities are endless.
So we are already trying to create a community, so by having everybody sharing their own code, so then the code can improve. The projects can get more and more interesting, and we can solve more and more complex tasks.
The world is so complex, so I've learned. When you're in the real world with a robot or anything, that you get this complexity, and there's something that emerges that you never would have expected.
There's a lot of potential here. What direction do you see yourself going in next?
Whichever direction they point me in, I guess.
Yeah, but what direction do you want to go in?
The one where I can do the most good for the world, I guess.
Me too, robot. Me too.